is we have to undo all these numbers that are around it until it just says W equals something. And we can't do that if there's W on both sides of the equation because we want just one W. So what I'm going to do for my first step is I'm going to subtract 14W from both sides of the equation. That's a balanced step because I'm removing it from both sides of the statement of equality. So it's like if you said Joe has a certain amount of apples, Rick has the same amount of apples. If you take 14 away from both of them, they still have the same amount because you did something fair, right? You took 14 away from Joe and 14 away from the other guy. I don't remember what names I just used, but okay, so that's a fair move. We can subtract 14W from both sides of the equals sign. 18W subtracted by 14W makes 4W, and just careful, that's not division up there. I can't seem to erase that. I was underlying that for emphasis. Okay, so this is what our equation looks like because I subtracted that 14W on the right side. That made it cancel out, so that's gone. Now, if I'm trying to get W by itself, next step is I'm going to subtract 23 from both sides of the equation. Because if I do that, a positive 23 minus 23 makes 0. So I'm just left with 4W on the left side. And a negative 21 subtracted by 23. Careful, you're going further back in the negatives there, right? That should be negative 44. It's like you start owing $21. If you take away $23, you owe more money. So when you add those digits together, 21 plus 23, that makes 44. And then the last step, to get W by itself, I'm going to divide 4 from both sides. Another balanced step, dividing both sides by 4, so they're both getting shrunk by the same amount. And I chose to divide by 4 because there's a multiply 4 right here. So that leaves us with W equals negative 11.